Okay, then number 3, Jared. 20x to the 16th. You had to multiply your coefficients together, 2 times 10, and then add your exponent. Number 4, Allie.
X to the 13th.
X to the what? I'm sorry?
13th.
13th. Good. Okay. And then number 5, Macy.
1 over x to the 3rd.
Good. When you add negative 5 and 2, you get x to the negative 3, and then you put 1 over that to make it a positive 3. Okay. How about number 6, Chris?
49x to the 16th.
Good. And number 7 was kind of hard. Did you get it, Vanessa?
12x to the 16th.
Okay, you're close. The x to the 16th is right, but
Did you 36?
you're getting there.
Wait.
Here, let me so you're going to distribute the 2, right? To everything that's in the parentheses. So you're going to keep your 3, and then you're going to have 4 to the what power? Second. And then x to the 16th. Okay. So what is 4 to the second power? 16, and then 16 times 3 is 48. Okay. Now the 3 did not get a 2 distributed to it because it was outside the parentheses. But when we distribute to a whole number like 4, that means 4 to the second power. Okay, how about number 8, Trevor?
7x to the 16th.
Good, 7x to the 16th. Travis, number 9.
1 over x.
Good, 1 over x, because you got an x left on the bottom. Kayla, number 10.
X to 19.
X to the what?
19.
Okay, did everybody else get that? Okay. There's different ways to do 10. We'll look at one of them. How about number 11, Christian?
X to the 20th.
X to the 20th?
Yes.
Okay, and then number 12 was a little tricky. Anybody, Scott, did you get that? So what did you get?
3x to the 10th.
Good. Okay, it's not x to the 30th, is it? Because we're adding. So it's like 1x to the 10th plus 1x to the 10th plus 1x to the 10th is 3x to the 10th. Okay, they're like terms. They're all alike, so we can add them together. Okay, so what did you get for the teacher told the student?
2 tenths.
Calm down, you are 2 tenths. You get it? It's a little pun there. Okay. All right. Questions on like 10 or 11. Do I need to work one of those? Anybody want me to work one?
You do number 10.
Mm-hmm. Okay, number 10. The x to the negative 5 times x to the 12th. We could do that first. What's x to the negative 5 times x to the 12th? If you add those together, you get x to the what?
7.
Okay. And it's still have to the 3rd power on the outside over x squared. And what do you do with the 7 and the 3?
Multiply.
Multiply them, so you have x to the
Converge.
over x to the 2nd. And then we're dividing, so we subtract the exponents and we get x to the 19. You could distribute the 3 also first and then do it, and you get the same answer. Okay, what about, how about 11? Does anybody need that one? Or any others? Don't be afraid to speak up. All right. Everybody good? Okay. Okay. Let's skip this for now. Go to exponent rules real quick. We're going to do part of this, and then we'll come back to it. This is what you just did. A to the m times a to the n. What do you do with the exponents? Add them. So you keep the same base, and so this would be a to the what?
M plus n.
Good. M plus n. So 3 to the 4th times 3 to the 5th is? Good. Keep the same base. Add the exponents. X to the
16.
and b to the.
A plus c.
Good. Okay, so to multiply terms that have the same base, you can add exponents. Good. They have to have the same base, though, for you to be able to add them, and you have to be multiplying. Okay, how about a to the m divided by a to the n? That equals a to the, good, m minus n. So 4 to the 7th divided by 4 to the 2 is 4 to the 5th. What about this one?
1 over x to the 4th.
1 over x to the 4th, because we have more x's on the bottom. Okay, so to divide terms that have the same base, you can subtract exponents. Subtract. Okay, a to the m to the n, that's like a power to a power.
A to the mn.
Good. We'd multiply them. We need a to the mn. So this one would be 3 to the 5 to the,
-16, but you have to put it over 1 to the
1 over,
5 to the 6.
good. Okay, and then x to the,
21st.
to raise a power to another power, what do you do?
Plus one.
Multiply exponents. Another way to say it is distribute the exponents too. Okay, we're going to do this one, and then we're going to learn how to do the next one. Okay, a to the negative n.
1
Over
over
n.
n.
Good. So 10 to the negative 5 is
1 over 10.
5 to the negative 1.
1 over. What? Wouldn't it just be 1 over 5?
Yes, 1/5. That's right. How about x to the negative 7? 1 over x to the positive 7. So negative exponents mean reciprocals or fractions. We're going to put reciprocals. It's where you flip it. Okay. So if it's in the bottom, you move it to the top. If it's in the top, you move it to the bottom. Okay, this a to the 1 over n, that's a fraction like 1/2 or 1/3. This is what we're going to learn to do today. Y'all haven't ever done this before. Okay? We're going to see what these mean. So we'll go back to the beginning of fraction powers. It says consider the function y equals 9 to the x and complete the table. So what we're going to do is plug in -2 for x. So we're going to have y equals 9 to the negative 2. How do you rewrite that?
1 equals 1 over 9.
9 to the positive 2? Okay.
Yes.
And then that equals 1 over what?
1 over 81.
Okay. So that's what we're going to put in here, 1 over 81. How about 9 to the negative 1? 1 over 9. Anybody remember what 9 to the 0 is? Nope.
There.
1.
1.
It's 1. Good,
Oh,
Scout.
yeah.
9 to the 1?
9.
9 to the second?
81.
Somebody figure out 9 to the third. 729. Okay. Okay, we're looking for a pattern as you go down.
Yeah.
The negatives are just 1 over.
It's just, yeah, it's just,
Okay, but like just look at this part. Just the y's.
They go up.
They do go up. How are they going up?
They're going up.
Okay.
By square.
By multiplying.
They're not squared, but
there.
multiplying by what?
The exponent.
By 9. Like if you start down here, 1 times 9 is 9, 9 times 9 is 81, 81 times 9 is 729. 1 over 81 times 9 is 1 over 9. 1 over 9 times 9 is 1. Okay, so you're multiplying by 9 every time. That's what exponents do. Okay. Like, because it's 9 to the x, you're multiplying by 9. If it was 8 to the x, what would you be multiplying by? 8. If it was 2 to the x, you'd be multiplying by 2. Okay. Okay, so now we're going to look at this part of the table between 1 and 3, but we're going to go by halves. Like 1, then 1.5, then 2. So we're wanting to see what 9 to the 1.5 is and what 9 to the 2.5 is. So this one we can put in our calculator. Clear everything out of y equals Then we're going to put 9 to the x. So that'd be 9 rooftop x. I'm putting that. But now we want to change the way our table looks because we have these halves in there. So we're going to second window. That's your table setup. We're going to start at 1, but the change is going to be, instead of going by ones, we're going to go by half, either 0.5 or 1 divided by 2, either way. Okay, and then they need to both be on auto. And we'll go to the table, second graph. And so 9 to the 1 is 9. What's 9 to the 1.5?
37,
9 to the second.
81,
9 to the 2.5.
243, and then 720.
729. Okay, we need to see why 9 to the 1.5 is 27.
Because, 1 times 9 is 9 and 25 of that.
It's 9
4.5. That didn't work. Good try though. Okay, what's going on here though? What, as it goes down? What are they multiplying by here?
3.
3. Multiplying by 3. We got to figure out where that 3 is coming from. Okay, so we're going to look at this. What is 9 to the 1/2 power? We're going to see what that is. Okay. So if you have 9 to the 1/2 times 9 to the 1/2, you add the exponents. What's 1/2 plus 1/2? 1. It's 1, isn't it? 2 halves, which is 1. So what's 9 to the 1? Okay. So then we're going to replace 9 to the 1/2 with x. So we're going to have x times x equals 9. What is x times x? X squared
No.
equals 9. And then how do you solve that?
Square root.
Square root. So x equals the square root of 9. And what is the square root of 9? 3. That's where this 3 came from. Okay, so 9 to the 1/2 equals 3. How did we get the 3 from here? We square rooted it. Okay. So let's look at this. What do you think 4 to the 1/2 would be? 2, because the square root of 4 is 2. Let's check it though. 4 rooftop parentheses 1 divided by 2 is 2, isn't it? Okay. How about 25 to the 1/2? 25 to the parentheses 1 divided by 2 is 5. How about 256 to the 1/2? Whoops. How'd that work? I should have had that parenthesis. There we go. 16. 16 times 16 is 256. This 42.25, we'll probably have to do it on the calculator. 6.5. Okay. Now, 3 to the 0.5 is not going to come out even.
1.732.
Okay, and then 80 to the 0.5. Why are these not coming out even?
Because they're not square root.
They're not perfect squares. That's right. Can't take the square root of them, can you? Without a calculator, what would 100 to the 1/2?
10.
Good, because 10 times 10 is 100. What would 144 to the 1/2 be? 12. Okay. What common mathematical process yields the same result as using an exponent of 1 square root? Okay. So now we know when a fraction is, an exponent is a fraction of 1/2, that we're doing the square root. But there are other fractions besides a half. We're going to see what happens when it's a third. So we're going to do y equals 8 to the x. So 8 to the negative 2.
1/64.
Okay, 1 over 8 squared, which is 1 over 64. Okay. How about 8 to the negative 1?
1/8.
8 to the 0. 8 to the third. What do you multiply by every time? 8. multiplying by 8. Okay, now we're going to use our calculator, and this is going up by a third every time. So we're going to find out what 8 to the 1 is, 8 to the 4/3, 8 to the 5/3. Okay, so you have to go back to y equals, and instead of 9 to the x, we have 8 to the x. And then go to second window to table set. And instead of going by 0.5, you need to go by 1 divided by 3. Can't put 0.3 in there, that's not the same. Okay. And then go to the table. And so what is 4/3?
Multiplying by
Yeah, you are. What's 8 to the 4/3 though?
2.
It's right here.
Oh, 16.
16. What's 8 to the 5/3?
32.
And 8 to the 7/3? 8 to the 8/3? And 8 to the 3rd. Okay, and it's doing what, Jared?
By 2.
Now, why would it be multiplying by 2?
Because 2 to the third is 8.
Okay, good. All right, let's see. We'll prove it right here. What is 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3? 8 to the 1, right? Because 1/3 is 2/3 plus another third is 3/3, which is 1. Okay, then we'll substitute x in for 8 to the 1/3. That equals 8. So what's x times x times x?
X cubed.
Okay, and instead of putting square root of x, we put the cube root of x, we put a 3 in this little area right here. The square root has a 2 there, but we don't put it. We just assume it's square root without putting a 2. Okay. So this is the cube root of x, not x, cube root of 8, right? So what times what times what gives you 8, Chris? 2. 2 times 2 times 2 equals 8. That's the cube root.
Do the cube root on.
Yeah,
Okay, I'm not going to show you in the calculator yet. I'll show you later. Okay. This says that 8 to the 1/3 equals 2. And that's why it's multiplying by 2 every time. Okay, so let's think of what could the cube root of 64 be? What times what times what gives you 64? What did you say? 4? Okay, and let's just say 64 to the 1 divided by 3 is 4. Just double checking it on the calculator. How about 216?
6.
And it is 6 because 6 times 6 times 6 gives you 216. Okay. Now 500 is not, yeah, it's going to be a decimal. Because it's not a perfect cube. Okay. What about 125 to the 1/3? 5. 5 times 5 is 25, and 25 times 5 is 125. Okay. Can you think of some other perfect cubes? What about 3?
27.
27 is a perfect cube. 3 times 3 times 3 is 27. Okay. How about we've done 4. What was 4? 64. What was 5?
125.
What was 6?
216.
216. Okay, you don't usually go much higher than that. You usually don't even go up to 6. But you know, what's 1? 1. Okay, and then 2 is 8. The root of 8 is 2. Okay. So what common mathematical process yields the same result? Cube root. Write down cube root. We got cube root here? Allie and Macy and Jared, y'all write cube root down here? All right, so now we're going to go back to this exponent rules. A to the 1 over n. You kind of know what it means a little bit now. It means the nth root of a. So if n is a 2, like 1/2, then it would be the second, or the square root of a. So look at this. 81 to the 1/2. That would be the square root of 81. You can put a 2 in here if you want, but you don't have to on square root. That would be what? 9, because 9 times 9 is 81. This would be the 4th root of 16. 2 times 2 times 2 times 2 is 16. It's 4 of them. This would be the what root? 5th root, and we don't know what that is because we don't know what x is. Okay? Rational exponents mean roots, or fractional exponents mean roots. So you know if there's a fraction for the exponent, you're going to have a root. Some kind of square root, 3rd root, something like that. Okay, now, m, sometimes you even have a number besides 1 in the numerator of the fraction. So m over n. Okay, we know what part of it is. The nth root of a to the m power. Here you go, Jamie. Okay, so the numerator is your power and the denominator is your your root. So how about this 81 to the 3/2? Be 80, the square root of 81 to what power?
3rd.
3rd. But what is the square root of 81?
So it's not
9 to the 3rd.
It's
Pretty big.
729,
Is it 729? 9 to the 3rd is 729. Okay, how would you write 16 to 3/4?
16.
Square root is 16 to the 4.
No, okay. You don't say square root. What do you say?
Cube root.
It's not cube root.
Oh, it's the 4th.
It's the 4th root. Remember, denominator is your root. We're going to draw a picture here in a minute to help us remember that. And then, what's the power? The 3rd.
That's 8.
So, right. Because the 4th root of 16 would be 2. Because 2 times 2 times 2 times 2 is 16. So 2 to the 3rd. 2 times 2 times 2 is 8. 2 times 2 is 4 times 2 is 8. Okay, then how would you rewrite this one? X to the 2/5.
5.
5th root of x to the
Second.
2nd power. Good. Okay, the numerator is the power. The denominator is the root. Okay, so we're going to draw a little picture of a tree. Because a tree has roots. Okay, and the roots of the tree are where? Yes, at the bottom. In the denominator. Okay. And then the sun gives the tree its power, and it is above or in the numerator. Let's squeeze that in there. Okay, it's just a way to remember which one's the power and which one's the root. Okay. So if you think of the roots of a tree, the bottom one is your root. Okay, we're not going to do this last one until tomorrow. And we'll practice some of these tomorrow. But we're going to... We got to do that really fast. When do we get out of here?
Right now.
Okay.